If you watched one of my previous videos and followed my instruction to install Intel oneAPI based toolkit, right-click Start, Search, Advisor. You can find Intel Advisor pinned to taskbar. This is Intel Advisor. Double-click it. You must have installed this software. In near future session, I will explain how to use Intel Advisor. This is my YouTube channel. A couple of years ago, I filmed Qt OpenCL SYCL Intel TBB MSBC GUI programming this series. In this series, I explained basics of Intel TBB. For example, I explained how to use parallel pipeline. Also, if you scroll down, in episode 47, in this episode, we installed Intel Advisor or Flow Graph Analyzer on Windows. I filmed this video on March 2020, before Intel oneAPI based toolkit was released. Now we don't need to install Intel Advisor separately, because this tool is now included in the Intel oneAPI based toolkit. Hello. Hi everyone, my name is Thomas Kim. Today is June 24th, 2022. This is my 11th episode about C++ 17, 20, 23 and other programming technologies. In this episode, we will learn how to use split node and join node. We will generate two numbers a and b, then we split to each function, that each function computes a square and b square. Then we join them to evaluate final result with TBB Flow Graph. Once you completely understand split node and join node, you are actually understanding 80% or more of Intel TBB Flow Graph. The remaining part is cancellation. I mean, we can cancel execution of our flow graph at runtime. I assume you have watched my previous video, episode 10. Please double-click this link. I would highly recommend you to watch these videos in this playlist. Scroll down, show more. Please double-click this link from episode 10. Show in folder, unzip it, rename 011, split, join, node. Copy the folder path, paste it in your working folder. Now start Visual Studio Code, open CPP 17 2023 parallel. In the Explorer, from folder 011, double-click Graph, Ctrl B. Please understand that we created this file in our previous episode, episode 10. If you haven't watched this video, please watch it. Otherwise, you may not understand my current session. Scroll down. Here, I will explain this part. This is one carriage return, then flush out to console. This is two carriage returns, then flush out to console. This is one carriage return but no flush. Two carriage returns, no flush out. I will add one more. Flush. Talk play fun. Flush. Flush out to console without carriage. Return. Now scroll down. Void test split join. Copy this. Paste it here. Actually, if you can generate data using broadcast node or input node and feed the data to your function node. Also, you can split the data flow or message flow, then after operation, join them together to produce final result. You can do anything with TBB Flow Graph. The remaining part is cancellation. About cancellation, I will explain in future sessions. Of course, there can be branching nodes too, but don't worry. I will cover them. Context for O N, we will start with 10. Flow Graph G Auto Generator TCR Random Generator int -5 5 Auto FN tuple. We capture generator by reference. Then n state int 0. TBB flow control, it should be L value reference FC. FC is not football club. We will return std tuple int int. If state less than n, we increment state, then return generator. Two random numbers wrapped in std tuple. We cannot modify state. State is declared here, but we can with mutable. Now, else football club should stop. This is not football club. This is flow control. Return empty tuple because our return type is tuple. Don't forget semicolon. Flow input node std tuple int int. We say ND. ND stands for node. Input. We need G, then tuple generator. This lambda here. Flow split node. We take std tuple int int nd split G. We don't need space here. We will make edge flow, make edge from ND input ND split. So we connected ND input with ND split because ND input node returns an instance of tuple. We can take an instance of tuple with split or fn square. This is function. Int value we return int. Don't miss semicolon here. Return value times value. Flow, we create a function node. Function node, we take int and return int. ND square A, we take G flow serial. We need function square. Copy, paste. This is ND square B. Please note that fn square, this function is recycled. One for ND square A, the other ND square B. Fn square, this lambda is used twice. Flow, make edge, we connect from ND split here to ND square A here. Now here is the problem. ND square A takes one int and returns one int, but ND split returns tuple, two element. So we select std get 0 from ND split. ND split has output ports. So from ND splits output ports, this output port actually returns tuple. From this tuple, we select zeroth element, so the first one. We extract the first int and pass it to ND square because ND square takes int as argument. This fn square takes int as argument and returns int. So this is return type. We copy and paste. We make another edge 1, then square B. Now auto fn sub std tuple int const lvalue reference tuple. It returns int. Don't miss semicolon here. if we are going to subtract two numbers, we have to take two arguments. Luckily, tuple can take two arguments. So, return std get 0. This is A tuple. This A. Then std get 1 tuple. We subtract two numbers, then return int. This is function. Flow function node. We take std tuple int, then return int and the sub. The first is G flow serial, then fn sub. Please understand that nd sub, fn sub takes tuple as argument. This tuple can take two elements, so this is the input value type of this fn sub. This fn sub returns int, so this is return value type. Now, here flow join node std tuple int. This is output type of join node. And the join, it takes G. We connect square A with the ND join, square B with the ND join, like this. Flow make as the source is ND square A. The target is ND join. Please understand that ND join has two ports. One port, two port. From ND square A, ND square A returns int. Input port 0 or input port 1, we have to select which port. Like this, std get 0 from nd join. This nd join has input ports. This is member function. Copy once again, paste. Now scale B, we select port 1. So in this case, the return value of scale A is inserted to port 0. This type, return type of scale B, is passed to second port or index 1. Now scroll down. We need to connect with the join node with the subtraction node ND sub. Flow make as from ND join ND sub. This is not sum, this is sub. I also made a mistake here. In the join node, we have to specify queuing policy. Flow queuing. I will discuss this graph policy in near future. Now, flow S-stream result or FN output. We capture stream result. It takes into value semicolon. This is not flow. This is talk, play, fun. Here, result, value, NL, new line character. New line, but not flush out to console. Flow function node, we take int and the output G flow serial, we pass FN output here. Please note that int specifies the parameter of this lambda. This lambda's return type is void, so we don't need to specify return type. Flow make edge from ND sub to ND output. We have to make edge between ND sub and the output. Now ND input activate. G wait for all. We flush out result to console. Flush out to console. I will remove empty space up to this point. Now open up your command prompt. cd 011 split join node clang ++ std c++17 graph.cpp ltbb 12 or c.exe, hit enter. CLSC. It works perfectly. Or you can do this too. Instead of stream, you can collect TBB concurrent vector into result. We resolve n or no +1. Then here you can say result implies back value. Now scroll down, print result, and there. Now try again. CLSC. Our result is displayed beautifully. We also want to have input. Scroll up. Here, std vector, std tuple int data resolve n +1. We capture data. Here data in place back, we copy, paste it here, then data back, last element. In this case, we used std vector of element tuple. This append tuple is used in the input node. We can use std vector because this nd input is executed in serial. However, in this case, append output, even if we specified serial, but it can be unlimited. Unlimited means multiple instances of ND output are concurrently, asynchronously executed. So we have to use concurrent vector. Now scroll down, copy, paste, data, I will put colon, data. We build again, CLSC. So -2 square, -2 square, then we subtract, the result is 0. So everything works correctly.